Imagine a world where our most sensitive work details like emails, files, applications, passwords lives inside a browser. Now think just how vulnerable that browser really is. In this episode, I talk with Audrey Adeline, a security researcher at SquareX and co-author along with Vivek Ramachandran of the book Browser Security Field Manual. The book takes us deep into the world of browser security with clear explanations, real examples, and practical code snippets. I had the chance to read one of the chapters and it was incredibly well. Listen in as Audrey takes us through her journey as an author, shares her experience and lesson learned along the way. She also shares a lot more insights into the browser security part, and I hope you enjoy the episode. This is Abhishek and you are listening to the Abhisek Cast. Welcome to the show. Let's start with the journey towards cybersecurity. So, how did you come into this field and where did you start?
Yeah, of course. It was really quite serendipitous. Right before this, I was actually an investor at Sequoia. So I was helping invest and evaluate a couple of cybersecurity companies there. And actually, funnily enough, one of the companies that I invested in is SquareX. At that time, Vivek was one of the first cyber people that I met. And I just thought they were solving a really interesting problem, right? The browser is really becoming the new endpoint, but most browsers really only have consumer grade security. So, had the privilege to follow their journey from day one. So, I think around that time as well, I was starting to think about, maybe I want to have a hand in startups and understand how people really build companies. So Vivek and I really just enjoyed working together with each other. I don't think there was a specific role he had in mind for me at that time, but we just decided to work together. And given my background, I was initially helping out with a lot of strategy, market research, and the go-to-market side of things. But given it was a new space, we really need somebody who could help with writing about the product, all the technical documentation, and the thought leadership surrounding the space. And I think thanks to the opportunity, I realized that I could write decently well for the technical audience, and that's where I started to do a little bit more research. And now the Year of Browser Bugs project as well, and a lot of that is probably thanks to my background in biochemistry. And one thing led to another, and we decided to publish this book together.
Right. So I just noticed a pattern. So I had an episode with Dakshita like a couple of months back. So she was also from an VC related firm, and you were also into some of the VC related firms. So I saw a pattern like SquareX getting people from the companies who are into investments and things like that. So uh, does that particular background helps a lot in learning security? That is a question that I have.
I think it's not necessarily directly correlated. I would say my particular role encompassed more deep tech companies, so it really helped. But I think one skill that you do learn in investing, especially in technology investing, is that you have to ramp up in a new area really, really quickly. And especially if you're working with early stage startups, you often, have the privilege to work with founders who think about the world and solving problems in a very different way. And I think as a result, you do get inspired and you do get sort of not molded in the traditional ways such that you can imagine different ways into approaching the way the world works. So I think cybersecurity is very much like that, right? It's very much about breaking things, about thinking about um, different ways to approach how to break things. And I think that definitely has helped to some degree.
Got it. Right. So, getting into the browser security field manual, and browser security is basically a niche for a lot of people even now, and a lot of people get started with web security, network security initially, but you are into cyber security and you started off with browser security. So, how was the transition towards learning browser security? What was the sparking point to write this particular manual? So, some words on that.
Yeah. No, that's a good question because browser security is quite a new space, right? There's not a lot of resources out there. And before I get into why we decided to write this book, um, I can share a bit more about why I'm interested in browser security. I think it's really the last frontier in cybersecurity, right? As you mentioned, most people started their career either in network security or endpoint security, maybe AppSec as well. Those are spaces that are very, very well explored. of course, a lot of work to be done. But browser is very interesting because if you look at the modern workforce, it's been a huge shift of the way we work. 80% of our time is now spent in the browser, right? So if you think about a lot of the local apps that we used to use, like Photoshop, Office 365, they're now all SaaS apps that we access to the browser. Similarly, we're not downloading as much files anymore, but instead we are, creating, sharing, interacting with documents on services uh, uh, like OneDrive or Google Drive, and these are all again access to the browser. So really, everything that your enterprise owns, the real treasures of the enterprise are now governed through the browser and your user identity in the browser. But there's still very, very little research and very, very little products out there that are truly designed to protect against web threats in the browser. And as a result, there's this massive gap that's very poorly understood. And even when we were writing the book, there's just so little structured resource out there. And it made us realize there's a huge gap that we need to plug in terms of education within browser security. And really in SquareX, the past year or so, we've been doing a lot of great security research. So a lot of our talks has been, published by major news media outlets like Forbes. And we've also attended a lot of cybersecurity conferences and spoken at DEF CON, Black Hat, RSA, and so on. So we felt like, why not put a lot of these great research into a structured way in which practitioners, students, or even security leaders can use to learn about this very new space.
Got it. That's a very great initiative. And I also had the chance to read one of the chapters, and it's really great. And it was very interesting for me. So I'm very new to browser security. I haven't been into that, but I got some initial knowledge through doing an episode with Dakshita. She explained a lot of things. And reading this, I was reading it yesterday, and like I was able to cover up around 10 to 11 pages. It was very new, like how the browsers are actually built with and the permission that which like most of them are overly permissive and how the attacks is then it was really nice. So uh building an book, so how does an process work? Like, so if say if you are going to build an book on a specific topic, and how do you plan for it? So what are the chapters that you plan for it? How is it structured? What are the research that needs to be done before writing the book? So, what are the struggles that you face while writing the book? So, some words on that.
Yeah, I think that's a great question. So, I think every great book should start with a little bit of history. So, if you read the first chapter of our book, it's a little bit about the history of the evolution of the browsers, right? Why does this browser security gap even exist? And the reason is really browsers are always meant to be for consumers in the beginning, right? It was never built as an enterprise SaaS app. It was more of a side effect of, more and more people going online, cloud storage becoming more accessible, that we see all these SaaS apps that enterprises are using. So kind of the way it's designed versus the way it's being used today is very, very different. And there's a lot of interesting history about, why the browser has developed so fast as well. So if you look at when the browser really evolved and added a lot of new features like WebRTC, WASM, it was really post 2008. Where Chrome, came into the browser wars and started open sourcing Chromium, and you started seeing a lot of development going on, and all these enabled, the high quality SaaS apps that you interact with to run the browser today. So I think that historical context is very important. I think you do see a lot of kind of videos out there that talks about the commercial aspects, about the drama around it, but not really provide an understanding on why this has impacted the technical and security challenges that we're facing today. So I think that's the very first part. And then post that, we had a lot of discussion on how we wanted to structure the book. One way is, of course, to do it by case studies, but we felt that one very easy way that practitioners can use to understand it is to map it towards different threat vectors that they could relate to in the endpoint or perhaps in the SASE SSC world. And this is really because, a lot of the threat vectors that you see in the traditional sense, so let's say ransomwares, are now manifesting in a very browser native way. And that's why we structured every chapter to focus on things like identity attacks, browser native ransomware, browser data loss, to help people understand, hey, look, this is your understanding of data loss in the past. How is it changing and evolving towards the browser? And what are the current limitations in terms of security? And and what are the TTPs attackers are using today.
Right. So, as you mentioned, a lot of different attack vectors that has been available on the browser side, and the EDR protections, whatever we have on the systems, have very minimal visibility to whatever is happening on the browser side, right? So, as SquareX browser extension, does that cover all these attack vectors and help the user stay safe from all these attacks?
Mhm. Yeah, absolutely. So typically, when it comes to browser security, you can think of it as three elements, right? So one is web attack detection and response. So that's kind of like how EDRs would protect, detect, and mitigate and threat hunt in the endpoint. So SquareX does act as an EDR in the browser. We call it browser detection and response. So that's the first aspect that covers everything from malicious files, malicious sites, to more modern web threat vectors such as browser extensions, identity attacks, browser native ransomware. So that's the first component. The second component is browser data loss, right? So in the browser, you interact with a lot of sensitive data. You might be copy pasting, let's say some of your source code into ChatGPT to get some support. You might be uploading and downloading files to your personal and work account. So how do you create policies that you can sort of control and observe how users are interacting with sensitive data in the browser? And how do you do that in a way that's not disruptive to their work? So that's the second element. And the third element is really private app access. So if you think about it, nowadays more and more people are working from home. They're using their own device. So this BYD culture is getting really big. How do you make sure that without using enterprise laptops that are managed, how do you make sure each and every individual only gets the right access to the apps that are necessary for work, especially for apps that are, a little bit more traditional? So one of the unique capabilities of SquareX is we can provide secure access through the browser to even very traditional apps that on mainframes that use thick clients. So I think that's a very, very critical part to ensure that only the right resources are being accessed by the appropriate people.
Right. So, just a scenario right here. Say I'm using Chrome or Brave browser. So I have SquareX already added to it. And let's say I do have an malicious extension also added to it. So in this case, does SquareX extension detect that I have an malicious plugin or an extension that's already in my browser? So does the SquareX extension do this?
Yeah, absolutely. We actually have a three-layered approach in the SquareX extension analysis framework. So the first part is, of course, looking at metadata analysis. So these are things that are public in the kind of Chrome store or whatever extension store you're using. So including things like developer reputation, permissions, maybe what sort of reviews and installation count there is. So I think this is pretty basic. A lot of vendors do this. But the two more important elements that are unique for SquareX is first the static code analysis. So SquareX actively looks into the code of every extension installed to see is there, code obfuscation? Are they, every API call they make, every network request that they could potentially make. We look at all the files, all the functions to see if there's any sort of potential malicious activity they can do. And the third element, which I think is actually the most important element, is dynamic analysis, right? How do you make sure you understand how the extension would truly behave at runtime? And I think you asked a really good question where whether an extension can monitor the activities of another extension. So in a regular Chrome browser, that's actually not possible. This is a restriction that's placed by Chrome and most of your other major vendors for the very reason that you don't want a malicious extension to monitor, your benign extensions, right? So what we've done is we've actually built a separate modified browser where we can install the extension you want to test, and we can go ahead and simulate using browser AI agents to see how the extension would react to different user personas. And as you probably know from reading the chapter, a lot of malicious extension only start displaying malicious behavior after a certain amount of time, maybe if they detect that there's a weak security environments or triggered by certain user actions. So it's really important to have that simulation being done by browser AI agents. So that's something that's very unique to SquareX, and it's something that we do for every single extension for our customers.
Right. So, as a follow-up question, so while I was reading the same chapter, so I got to know about how Chrome store is actually monitoring the extensions where it is only doing the static analysis part and leaving out the dynamic part, right? So since SquareX is also doing an static analysis and dynamic analysis at this point, so does the static analysis differ from how Chrome does it and how SquareX does it? Do you guys have an proprietary scanner with you to
Mhm.
find new vulnerabilities on the code?
Yeah, that's a really good question. So I'll answer this in two parts. So the first part is how Chrome actually does it, right? So we're actually doing an expose this month, which will come out in 2 weeks, on the limitations of DevTools that existing browsers have. So if you're familiar with the DevTools in the browser, it was actually really invented to inspect sites, right? It was never really invented to understand how extensions work. But extensions have special superpowers. So I'll give you an example. In a site, any kind of network request is probably made by the site itself. But when it comes to browser extension, what it can do is it can inject the script and then make a network request through a site. So for a developer tool, it has no kind of bearing and understanding on if a network request is made through a site. Is it done by the site's JavaScript itself, or is it done by a script that's being injected by a malicious extension? So that lack of context prevents them to do any sort of real analysis there. And that's understandable, right? Hundreds and thousands of extensions are being uploaded to Chrome Store for approval every single day. There's no way that they can do such an extensive way of assessment. It's very similar to how you can't expect Android or iOS to inspect every single app in such a thorough security manner. And then the second aspect is the static code analyzer that we've built is completely different. Um, we basically have trained them with a huge data set of existing known malicious extensions and benign extensions. So existing code analyzers are not, very specifically trained for extensions. They're much more for regular code, your like regular apps. So we have built one that's proprietarily trained for extensions that understand the context of different permissions and how they vary between different extension environments and, let's say, Chrome versus Edge versus Firefox, because as you may know, the same named permission might do slightly different things in different browsers. So that's something that is completely proprietary that we have built.
So this makes me understand what extension actually does and how important is to do all these things. So as the first part of the book has already been released at RSA conference, and how was the release and what are the responses that you get? So some words on that.
Yeah. So at RSA, we did a sort of soft launch where we only shared it with around a couple hundred CISOs. So it's sort of a close launch. And to be honest, the response has been very overwhelmingly positive. We didn't expect so many people to come back to us with feedback. So what we've done is we've actually incorporated a lot of this feedback in the second edition of the book, which we will launch at Black Hat in just under 3 weeks now. And there we actually have collaborated with a bunch of, security leaders, many of them CISOs or Fortune 500 companies. For example, we have Rati, who's the former CTO of Verizon. We have Rahul Kashyap, who's the former CISO of Arista Networks. All of them help us give a little bit more of an industry perspective on how they're observing these different threat vectors are impacting their enterprises, as well as how they expect them to change and evolve over time. So as you can see, the first kind of edition of the book is very technical, very practical. So I think this gives us a more holistic view on, how industry leaders are thinking about these threat vectors.
So let's get into a little bit about the book chapters and things like that.
Mhm.
So the exact chapter which I was able to access is that is into malicious browser extension,
Mhm.
and there were a lot of different attacks that was mentioned, and I was able to go through them. So
Mhm.
I would like you to give us some glimpse on how these attacks works and some idea on that. I don't want to reveal more of the book, so
Mhm.
that the readers could get the book and experience
Yeah,
it.
Yeah,
Yeah.
of course. I'll share with you two that I think I find very interesting. So the first one is polymorphic extension. So this was actually discovered by a research team as part of the Euro Browser Bugs project. So what this extension does is imagine an extension that pretends to be, let's say, an AI marketing tool or any sort of tool, right? And they might really have these capabilities. So the user will go ahead and install it, see that the functionality works, and completely forget about it after some time. And then post a certain time trigger, it will go ahead and inspect what other extensions are installed in your browser. And it will, let's say you do have a crypto wallet or a password manager installed, it can take a look at its UI elements and everything, and it can completely morph itself into that particular extension, everything from its icons, its pop-ups, its login page, and disable the real extension, such that the user thinks that they are now interacting with, let's say, your real password manager, enters the master key, and then moments later, once they've exfiltrated that password, they can go ahead and log in to your account in their own browser. So now the attacker has complete access to your entire password vault. If it's a crypto wallet, they have access to all your secret phrases and they can transfer all their money. So I think this is really interesting because it really shows the superpower of browser extensions and how little people are able to understand what they do. And I think the second attack that was really interesting is the Cyberhaven attack that happened back in December. And what happened was essentially this is very interesting because we ourselves was attacked by this particular threat actor group. But we were lucky to be able to detect it ourselves. So essentially, what happened was this threat actor pretended to be Chrome Store, and they went ahead and emailed a bunch of developers and said like, hey, you are violating some sort of developer policy from Google. Please quickly accept these new policies in order to prevent your extension from being removed to Chrome Store. And the funny thing is, Abhishek, is it's super easy to get the emails of these developers because it's all displayed in Chrome Store. So all they have to do is mine that through and then send the very same email. And that email is actually sent through Google's official OAuth page. So once you click the link, you actually get redirected to an official OAuth page on Google, which where a malicious app will go ahead and ask for permissions to completely access your Chrome store to edit, change, and upload, a certain update. And what happened was, given that the developers were already in a state of panic, they'll go ahead and accept this. And this allows the attacker to go ahead and upload a malicious version of the extension to Chrome Store. In the case of Cyberhaven, 400,000 of all their users got access to this malicious version that could spy on them, exfiltrate data, cookies, and everything. So this really shows you that, it's super easy for an attacker to, gain control of a previously benign and well-trusted extension, and that the user receives no notification of this change, right? They have no idea because all of these are done through legitimate processes and legitimate functionalities within the browser.
Right. That's a really interesting attack. So I just have a follow-up question on the polymorphic extension.
Mhm.
So I'm just clarifying a few things. So uh, let's assume a scenario where I have malicious extension in place, and I also have an extension that controls my crypto wallet.
Mhm.
So I'm just trying to understand this part. So if that malicious extension is polymorphic, what it will try to do is it will understand that I have a crypto wallet in it, and it will
Mhm.
mutate itself to look like a crypto wallet. Is that correct? Or
Correct.
I
And
haven't.
they will also go ahead and disable your crypto wallet so that in your pin bar, it looks like there's only one crypto wallet, which is now the fake one from the polymorphic extension.
Okay, okay. So, since we already spoke about the managing part of like extension, understanding the other extension and monitoring its activities, so
Mhm.
is there any diminishing effect right here, or the malicious extension will be able? How will that be like finding out there is an crypto wallet in my browser, and so. And how will like since you mentioned that there would be a restriction on controlling the other extension
Mhm.
itself, right? So how does this actually work?
That's a great question. So what this can be done by an API that Chrome actually provides called Chrome Management API. So it provides extensions with the privilege to be able to see what other extensions are in place. Now, you bring up a good point, because what happens here is it's a high risk permission that usually triggers more inspection by Chrome Store, but it is a possible Chrome API. But again, you don't actually need to disable other extensions. You could potentially just morph into it directly if you wanted to.
Okay. So let's talk a little bit about the Chrome's manifest files and
Mm-hmm.
the steps that was done by Chrome to control these kind of attacks. And there are like
Mm-hmm.
different versions coming up, and also there is I think there was a part on the book which was talking about the DEFCON talk, which actually references to sneaky extension which actually bypasses the latest security controls that Chrome Store is trying to provide. So some words on that point.
Yeah, of course. So the manifest is essentially, Chrome's way to kind of instill some best practices. And recently they launched MV3. So last year, I believe, mid-year, they implemented it. And this basically, sets out different, rules on, what sort of APIs you can use, what sort of permissions you can use. But really, a lot of the changes that they have made is primarily to prevent, ad blockers and, just ad crawlers in general. And unfortunately, there's a massive misconception that, being MV3 compliant means being secure. But as we have showed in our DEF CON talk, it's still very possible for you to go ahead and create a malicious extension that is still MV3 compliant. And there's a couple of reasons to this, right? The first reason is that every single permission that is provided by Chrome is extremely broad and powerful. So let's take the audio capture API, for example. Here they can capture, once you give permission to that, they can capture all audio, right? There's no easy way for you to distinguish what sort of audio they can and cannot capture. And similarly, if you provide, permissions to, read and write a certain site, you can't limit, hey, I don't want you to read and write PII or any other sensitive data. So there's really very little control. And I think what's important to understand is also a lot of these permissions are being used by legitimate extensions like Grammarly, your VPN. So it's very, very difficult for security teams just by looking at the permissions they request to understand whether it's being misused. And I think that's a critical part, right? Because it's not really a software bug, it's just a implementation, or misuse of existing features. And the second point is something we've briefly discussed before, is the fact that, even benign extensions can turn malicious. So sometimes a lot of security teams would go ahead and inspect and look, okay, it's MV3 compliant, and it looks like, post-static code analysis, there's nothing wrong with it. But as we mentioned earlier, it's super easy for an attacker to go ahead and compromise a developer, compromise, an extension, and go ahead, or maybe even purchase an extension, right? So one example that we mentioned in the book is the Great Suspender, which is a very popular extension that people had used in the past, but it got bought over by a threat actor, and there's no notification to the end user for that. And I think a more recent example is the Gecko color pick, right? That was disclosed with some other 17 extensions. Some 2.5 million people realized that they were actually using legitimate extensions that either got hacked or got purchased by attackers. And as a result, they have been spreading spyware through them. So I think it's really important to understand that a lot of extensions can only display malicious behavior upon a certain trigger, whether that's time or user action, or being compromised later on. So MV3 really is not a good definition of being secure.
Right. So this makes me understand that it's having a lot of dangerous permission and it's overly permissive at a lot of times, right? So does this mean that there is a need for a new browser to come up with more granular security controls? And also, a follow-up question for this question is that from an user's perspective, so since there is a lot of dangerous permissions coming out, so how should I verify and install an extension?
Yeah, that's a good question. I think the best practice is, of course, always if you don't need an extension, either uninstall it or disable it. That's the safest way. But as we know, security doesn't work like that, right? You can't just tell people to not use things. So, to your question on can a browser be more granular? Technically, they can, but at some point, attackers are still gonna figure out how to exploit and misuse these APIs, no matter how granular you make it. And at some point, it's very similar to the Android example I mentioned, right? It's just like how Chrome can't also be responsible for all the phishing sites that are being created over the internet. They can't be responsible for every single extensions that being put out there. So I think this is a very critical issue, right? Because there's a shared responsibility between the browser vendor, the extension provider, and the end user to secure themselves from all these malicious extensions. And there's kind of a push and pull on, okay, whose fault is it if something happens, right? So really just very similar to how you would have an EDR to defend against threats in the endpoint, and how you can't expect the OS providers to really take care of every single app that people are installing. You really need a browser native security that really understands the context of extensions and know how they behave at runtime to defend against them. You can, of course, hope that one day the browser vendors would do it, but as you know, similar to the OS, that's not their primary business, right? Security is something that they do as a hygiene. They are responsible for, plugging in CVEs. They're responsible for, you know, solving software vulnerabilities in the browser. But, to be honest, and most of our YOBB disclosures to the browser vendors, most of the time they just say won't fix because, a lot of the vulnerabilities we're exploiting are really architectural vulnerabilities that are misusing what they call features that are work as advertised. So, it's not really their responsibility, nor is there a lot of incentive for them to do it. And that's partly why we're also publishing a lot of research with YOBB to hopefully raise awareness among browser vendors as well, to collaborate with security vendors and users alike to stop this problem.
That sums up that I think I should definitely have a browser controlling extension like SquareX one in my browser to control them. Right. So, since you have given DEFCON talks, right? So it's a very big uh, conference on cybersecurity, and it's a dream for me to give a DEFCON talk, right? So, how was your experience on attending DEFCON and giving a talk over there? So, how was the journey like? So, how did you prepare for the CFP? And
Mhm.
so, just some words on that journey.
Yeah, so I actually did not speak at DEF CON. My very lovely colleagues did. At that time, I had just joined SquareX. I will be there this year, though. My first talk was actually in B-Sides and then very shortly after RSA. But I mean, I think the CFP process is very similar. I think when it comes to research, there's always a question about, hey, what is the impactful research that you want to display? And I think there's usually two categories for that. The first type is software vulnerabilities, and the second type is architectural vulnerabilities. And I'll share more what I mean by that. Software vulnerabilities are, things like, okay, within Chrome, there's, some sort of exploit that you can do. You can go ahead and report that. And it's very important, right? A lot of very respectable hackers that I know build their career out of it. And it is a very important element to keeping all of us safe, but it is also something that can be easily solved by a patch, right? So you see that I think we just pulled some data recently. I believe Chrome would kind of patch around 300 CVEs every single year. But when it comes to architectural vulnerabilities, these are attacks that are really exploiting known functionalities or architectural limits that cannot be easily solved by a patch. So I'll give you an example. We discovered an attack called full screen BITM, where essentially it's a variant of browser in the middle, but it's a full screen version. And what it exploits is really the fact that the full screen API can be called by any user action. So it essentially creates a pop-up where it's directly RDP into the attacker's browser. So as a user, I thought that I was just being redirected to a new site, but really I'm now interacting with the attacker's browser. So if I enter any sort of passwords there, it's completely observed by the attacker. And that kind of vulnerability that we're exploiting here is that, hey, when you call the kind of full screen API, all it requires is for you to click a button. But it never kind of specifies that it has to be a full screen button. So for an attacker, they could sort of disguise, let's say, a full screen button as a login button. So the user thinking that they're clicking the login button, they're actually triggering a full screen API. So these are things that are, again, not super easily fixable because, again, the API is working as advertised from the browser vendor's perspective, but it's being misused, right? So it's much more difficult for you to sort of fix from a software standpoint. And then similarly, a lot of the kind of exploits that we share are, on architectural limitations of existing enterprise security solutions. So for example, why, secure web gateways can't detect certain attacks in the client side because they're in the proxy layer, they have very little visibility into browser. So these are things that are not easily fixable and are architectural in nature. And I think that's something that a lot of these conferences look for because of the longevity of these vulnerabilities.
Understood. So that's an great perspective. So I can able to understand why these attacks are still there and what are the kind of landscape it is having access for. So, since you're leading the Year of Browser Bugs program at SquareX, so how does the project look like? So if you had to tell about a day about and research person, so how does that look like? So how do you start and things like that?
Yeah, good question. Yeah, I think very similar. There's a lot of ideation going on, hey, how do we make sure that we focus on attacks that are architectural in nature? And I know that we only post the ones that are successful, but there's a lot of trial and error. So a lot of ideas that we try, we realize that either maybe they're not, impactful enough, or maybe they don't work. And every time we discover an attack that doesn't work, it's great news, right? It means that we're secure. But again, I think because the browser is something that moves so quickly, every time there's a new feature that's being launched, so things like WASM, right? It's not very well researched. So we were able to find a lot of ways that it can be exploited. And I think really understanding the architectures of, existing solutions and how they work, not just from a technical perspective, but interestingly from a business perspective. So I'll give you an example. When it comes to secure web gateways, right? Why were we able to, do look at last mile reassembly attacks and a lot of their exploits? So it's really to understand their business model. So for example, we discovered that, hey, most secure web gateways only scan up files up to 40 megabytes or 120 megabytes in size. So as an attacker, you can simply just create a large file and hide a lot of malicious content in there. And the reason is not because it's not technologically feasible for them to send every single file to their cloud. It's because it's going to be incredibly expensive. So understanding, the way the SLAs and a lot of the kind of operations behind these large enterprise security companies are also very important. But yes, I think a lot of the spots that we exploit are usually very new areas of technologies that are understood. So, for example, in DEF CON this year, we'll be taking a look at how we can exploit passkeys. A lot of people are trying to move from passwords to passkeys when it comes to authentication because they think it's safer. But really, it only appears safer because it's newer and it doesn't have decades worth of exploitation, right? Similarly, we recently did a release on browser AI agents. So operator, computer use, why they're much more vulnerable than even your employees because they're not really security trained, right? So looking at new technologies and how attackers might think about exploiting them. So maybe that's a good way to summarize it, right? Understanding the attacker mindset and taking a look at, if I were an attacker, how I would go ahead and exploit the newest working tools or working trends like extensions and browser AI agents.
That's a great answer, by the way. So, since you have been into research and you have been doing research every day, right? So, if we could ask you the one underrated skills that researchers lack, so what would that be?
I think, I feel like there's a lot of great research, but I think it's very important to know how to communicate your research. And I think a lot of researchers are incredibly technical. They're incredibly passionate about what they do. Um, and there's always this urge, even for myself, to share a lot of the gory technical details that we went through to discover this attack. But I think it's really important to know your audience very well, right? So it's always good to assume that your readers don't understand everything, and your goal is to make them understand, not to share what you're most interested in. And this really applies to technical audiences too, because even if they are technical, they might not be as deep as you are in that specific space. And to be honest, you are the researcher. So by definition, you are the expert, right? So it can be tempting, again, to talk about a lot of, technical details, but it's much more important for you to know what key message you want to deliver and get that across. So I'm always of the philosophy it's better to have three great arguments than, three very average ones with, seven bad ones. So and I think the other aspect that a lot of security researchers miss is, they have a lot of cool technical exploits, but then, fall short in the social engineering part. But the truth is, a lot of the attacks that really get to people are not your, super complex technical attacks. It's actually the social engineering behind it, exploiting the urgency among people. And I think it really makes the difference between a good and a great attack is if you truly understand the human psychology and the workflow and emotions involved in people's daily work. So simple things like using the relevant apps that your target audience actually are using, exploiting the urgency of, let's say, job seekers or certain promotions for popular brands. Um, and how you make subtle design choices to make your attack even more convincing. So it's sort of that last mile after having a very interesting technical discovery that makes an attack really, really effective.
Right. That's a great answer, by the way. And so, as you are a researcher and you'll be following a lot of different blogs, feeds, right?
Mhm.
So, if you can call out a few things like an podcast or an blog series, anything that would be very useful in terms of reading browser security or on the whole, on the research point of view or cybersecurity, what are some of the resources?
Mm-hmm. Yeah, good question. I like a lot of independent research blogs. So for some, Mr. Docs D0X, I think he writes very, very well. Of course, you have your mainstream media as well, like Dark Reading, Bleeping Computer. They're very good to understand, what are the most kind of recent attacks that are happening, but they don't tend to share very technical details on how the attack happened. Sometimes Microsoft shares very good blogs, but oftentimes I find that it's a lot of the kind of independent researchers that are usually credited in a lot of these news articles. So my discovery process is typically going to Dark Reading or, Microsoft or, larger blogs, and then they'll go ahead and credit these kind of smaller independent researchers where you can find more detail on exactly how the attacks happened.
Yeah. So, since you have been working for a while with SquareX, so how has that been? So, you're also working with Vivek, who is a very well-known person in cybersecurity. So, how is working at SquareX look like?
Yeah, I mean, honestly, it's incredibly exciting. Like, things are moving super fast in the browser security space. I think we are very lucky with the timing that we're at in this particular industry. Things are heating up. A lot of competitors are getting funded, and so are we. We're starting to see a lot of customers getting interested and coming to us saying that they need browser security. Even last year, there was still a lot of customer education that we needed to do. And still today, that's something that's, top of mind for many browser security vendors. But you're really starting to see the tipping point of, people starting to see that people around them getting exploited. So I think it's really a very, very interesting space. And as you mentioned, Vivek is very experienced, and he's probably one of the rare people who is both extremely technical but understands the business of cybersecurity very well. Um, and I think again, it's that balance about, like, you built this great product. How do you strike the balance of sharing how advanced and how unique your product is versus still speaking in a language that people can understand and appreciate and relate to, especially if they don't come from a browser security background, which, to be honest, most customers won't be, right?
It's great to work with such a person, right? So that's all the questions that I had for you. It was great talking with you, and all the very best for the second edition book release. And I'm very excited to. So thank you so much.
Thanks so much, Abhishek.